Okay, my name is Ghafari and I will explain the question to you.
Do heavier cars really use more gasoline? Suppose a car is chosen at random. Let X be the weight of the car in hundreds of pounds and let Y be the miles per gallon or mpg. The following information is based on the data taken from Consumer Reports. This is the table the weight of the cars, X in hundreds of pounds and Y is the miles per gallon or mpg. So we got the 16 data, and the question is plot the sketched diagram, calculate the sample correlation coefficient between X and Y, calculated the least square estimate for estimated intercept A and estimate slope B. Would the null hypothesis that there is no effect of X and Y be rejected at the 5% of level significance? What proportion of the Y variability is explained by the fitted regression line? So we get the solution for the sketch plot. We just input the X and Y point from this data from the table, and we draw in the XY plane. We get the result in here. And for the B, calculated the sample correlation coefficient between X and Y. So first thing first we do is to draw the table. There are X, Y, X squared, Y squared, and X times Y. So we get this number for the X square is from this data square, and we get the result in here. And for the Y we get the square this number and we input in this area, and for the XY we times the X variable and Y variable and we put in here. So we get the sum of the X is 299. For the sum of the Y is 167, and for the sum of the X square is 11,887, and the sum of Y square is 3,773, and for the sum of the X times Y is 5,814. So for the sample correlation coefficient between X and Y, we have to calculate correlation coefficient R, which is the formula is n times sigma xy minus sigma x times sigma y divided by root square of n of the number of the data times sigma x square minus sigma x square and times root square of n times sigma y square minus sigma y, and then we square it. So we put number in n. The number of the data is 8. We times the sigma xy from here, and we get the sigma x from here, and we get the sigma y is here, divided by root square of the n is the number of the data, and the sigma x square we just put all of the number in here. So we get the final result is for the R minus 0.95. And then we moving to the C, or least square equation. We have formula this x bar equals sigma x divided by n. As we can see before, we get the x sum of the x is 299, divided by the number of the data is 8. So we get the result 37.38. We get the y bar. The formula is sigma y divided by n. We get the sigma y 167 and the n is 8, so we get the number 20.88. So next we calculate b. The formula is n times sigma xy minus sigma x times sigma y divided by n times sigma x square minus sigma x and y square. So we get put all the number in here. So we get the final result for the b is minus 0.6. And then we have to calculate the a, which is the formula y bar minus bx bar. So we get the y before is 20.88 from here, and we minus it with bx, which b is here, minus 0.6 times x bar. We get the x bar is 37.38 from here, and we get the result 43.31 for the a. And next we have to calculate the equation for the y equals 43.81 minus 0.6x from the equation y equals a plus b times x. So we get the d in here. So the d, we have to calculate the null hypothesis that there is no effect, x and y be rejected at 5% of level significance. First we have to draw this table. We get the x, y, sxx, xx, y, year regression, 8 square SSR, SST, SSE, and SYY. So we just input, we get the result in here, number using the Excel. So this is the total of all of the data, and we also get the mean from each of the data, and we have to put the ANOVA with the source SSR, SSE, SST, and SS. We get the SSR into 156.88 and so on for the SSE, SST, and MS. And for F calculation we get the 51.83. And we move into the regression model. Y equals to 43.33 minus 0.6x, and we got the regression line test. For the hypothesis 0 is beta equals 0, and hypothesis 1 is beta not equals 0. We get the critical area and test criteria. For the critical area, the alpha is 5% and V1 is 1, and V2 we get the formula n minus 2, and we get the 8 minus 2 equals the 6. We get the F table. F 0.05, 1.6 equals to 5.99. So we get the test criteria. Rejects hypothesis 0 if fh bigger than equals f alpha and accept if fh less than f alpha. So the conclusion, reject hypothesis 0 because the fh is 51.37, which is less than 5. Sorry, there is a mistake for the conclusion. Reject hypothesis 0 because fh is 51.37 is bigger than equals 5.99. So we move into the E. So the E is what proportion of the X variability is explained by fitted regression line. So we get the R is minus 1.95, and for the R square is minus 0.95 square. We get the result 0.9025, and we get the 90.2% of the variation can be explained. So that's all for the number 2.